Hello everyone. Today we restart our lecture and we will have a second lecture, lecture number 2, and our lecture will be devoted to the words. This and the third lecture will be devoted to the words. What is a word? Let A capital be a set which can call an alphabet. A word W on alphabet A is a finite sequence of elements of a set A, yeah, where A1, A2, so on, AN, where all AI belongs to A capital. The set of all words on the alphabet A is denoted by A with star, and is equipped with the associated operation defined by concatenation of two sequences. We have two sequences, A1, A2, is so on, A1, or N, B1, B2, so on, BM, and concatenation of these two sequences. The sequence is the following: A1, A2, so on, A1, B1, B2, so on, BM. There are no problem to show that this operation is associative, and this allows us to write the word W in the following way. As usual sequences, we write it as we write words in our writing in school, in other, and we use such writing instead of W, of such symbols. By defining each element A small with A capital with the sequence A, such with A. So every element of the alphabet A is called a letter. The empty sequences is called the empty word, and it will be denoted by 1 or simply epsilon. This element is natural element for concatenation. Is it true that it shows if we have the word of the form, for example, we have a alphabet A and B, yeah? And so we can consider the word ABA, yeah? And if we write on the left ABA is empty, the word, yeah, is equal ABA, yeah? And if you write on the right, ABA is equal ABA, yeah? So in our case, letter in our alphabet A capital, we have two letters A and B, yeah? And all words have a form A, B, B, A, B, A. So we have the order symbols. A consists of the letter A and small and B small, and all letters in our case, all words in our case has this such form, where I identify with the word, identify with the letter A or B in this formula. Good. So if we have an alphabet A capital, then the set A capital star of word is equipped with the structure of the monoid, yeah, with such structure. And the monoid A capital star is called the free monoid on the set A, or the free monoid over the set A. It is obvious that in our definition, alphabet must be a non-empty set. If when our set is singleton, when A consists of one element A small, yeah, all walls in A star are the following. So empty set, epsilon, A square, A in power 3, and so on, A power n, and so on. Also, the set of non-empty words our an alphabet A capital we denote by A sub plus, and this set with the usual operation concatenation of the word is called the free semigroup our or on an alphabet A capital. So what we have? We have that as a free semigroup on A capital is equal the free monoid on A capital without empty words, which is denoted here by usual symbol 1. What is the length of the word? If we have the word the form a1, a2, so on, an, where I belongs to A, the length of this word is called the member n of letters in this word. Yeah, it is suppose that the empty word or natural element of the free monoid has the length which is equal 0, yeah, and the function we supposed every word its length is a morphism from a star into additive monoid of non-negative integer. So we propose prove this sentence for you, and next we use the following notation. S in power n, so is consists of such word of the free monoid over A, and with the properties is the length of these words is less or equal n minus 1, and by this symbol we denote all words of free monoid with a length less or equal n. So in general case we have that such that is empty set, and such that is such that consists of the natural element of the free monoid. Also, for a subset of B of an alphabet A, we denote by such symbol the number of letters of the word W, which are in B capital. Hence, we get the following: the length of the word W is assumed by letter from alphabet A capital of the symbol of such. For any word of free monoid, we put the following: the elf of W consists of such letter of alphabet such which contains which has the following property. So the word W contains letter A, at least one, yeah. So, and hence we guess that there are all letters which lies in this word, yeah. Is a set of letters occurring and this set is a set of all letters occurring at least once in W. Also for subset X of Riemannoid, we put the elf of X is the union of elf of X small, so that X small belongs X capital. So if we have any word of Riemannoid, this word is called a factor of a word X from this monoid. If there exists a word the U and V from Riemannoid, such that X is equal to UWV. The relation is a factor of is the partial order on a Riemannoid. What is a partial order? Just a moment. So, what is a partial order? Partial order. On a set X. So the partial order, we shall denote this the partial order by less or equal, yeah, is a relation on set X which has the following three properties. X is less or equal X for all X from X. The second, if X is equal or less Y and Y is equal or less X, this implies that X is equal Y for X, Y from X, yeah. This the first property is very well known for us. It's reflexivity. As I said, the second is antisymmetry. Antisymmetry. And the third, transitivity. What we have if X is less or equal Y and Y is less or equal to Z, this implies that as X is less or equal to Z for X, Y, and Z from X. Transitivity. This property is called transitivity. So, a partial order on the set is a relation or binary relation which has the following property. This relation is reflexive, antisymmetric, and transitive, yeah. If in addition the partial order we shall denote by partial order. So if a partial order has the following property that X is less or equal Y, or we have Y is less or equal X for some X, Y from X, yeah, then we shall call it A, X, and Y are comparable. with respect with the respect to special order less equal on X. And when the special order has the following property 5, so any two elements of X is comparable, then the special order is called linear order. Linear order on X, or total order, These two terms are equivalent: linear order or total order on X. Also, the set with partial order is called partial order sets. The set with linear order or equivalent, the set with total order is called a linear order sets or chain. So, okay. So, and we get the relation to be a factor of is a partial order on a star. There are no problem because the proof of this statement is very simple. So if we have, it's obvious that X is equal epsilon X epsilon, we have this relation is reflexive. If we have that X is equal A Y B and Y is equal CX D, this implies that X is equal I CS dB, yeah, and this implies that AC and dB is equal empty set, yeah, and hence A and C and D and B are empty word 2. This implies that X is equal Y, and hence the property antisymmetry holds for this relation. And of course, if A is equal YB and Y is equal CZD for some A, Y, and Z from the Fremenoid, then we get that A is equal A CZ dB, which implies that X is less or equal to Z. And less or equal, we denote the partial order of video generated the relation to be a factor of. So a factor W of the word X, our Fremenoid, is called proper if W does not equal X. A word from Fremenoid is called prefix of a word X from this Fremenoid if there exists a word U from Fremenoid such that X is equal WU. So also the prefix double v of the word x is called proper if w does not equal x. The relation is a prefix of or to be a prefix of is again a partial order on the Freemonoid, and it called the prefix order. Later we used this prefix order on the Freemonoid. Also we write, in this case we write w less or equal x when w is a prefix of x, and w is less of x when now w is prefix of x and w is not equal x. This special order has the following fundamental property. For some word x, we have that w less or equal z and w prime less or equal z, then words v and v, w and w prime are comparable. That is, w is less or equal w prime, or w prime less or equal w. In other words, if w is equal w prime u prime, then either there exists a word as from Freemonoid a star, so that w is equal w prime s, and hence we get the su is equal u prime here, yeah. Or there exists t, a word t from Freemonoid a star, so that w prime is equal wt, and then we have that u is equal t u prime. In entirely symmetric manner, we define as a suffix w of the word x by the following: x is equal v w for some word v from Freemonoid a star. Let a subset P of Freemonoid a star we shall call the prefix closed if it contains the prefixes of its elements. So this means that if we have u v belongs P, this implies that u belongs P. Oh, for example, what is prefix closed set? Consider the following set. So we have alphabet. It consists of two elements, A and B, and we put P is equal A, B, B. Of course, P is not prefix closed, but if we consider P prime, it consists of A, yeah, B, B. So we get that all P prime contains all proper prefix of P prime, yeah. And we put also, you see right here, epsilon as a. There are problems with definition of prefix closed subset. So because we may assume that every empty word is a prefix or a suffix any word, yeah. So a suffix closed set is defined symmetrically. Let me consider totally ordered alphabet A or linearly ordered alphabet B. The lexicographic or alphabetic order on a free monoid A star is defined by the setting U lips V if U is proper prefix of V, or U is equal RAS, V is equal RBT, A is less B for AB from A, and R, S, and T are words from free monoid A star. The lexicographic order on the free monoid has the following nice property. If U lips V, if and only if W U lips WV for any words U, V, W from free monoid. So I recommend you to prove this property, but this property is very simple for proving. Similar, we introduce a radix order on a free monoid. The radix order on a free monoid A star is defined by setting U less V if the length of U less length of V, or if length of these words coincides, and U lips V is the lexicographic order. So I propose for you that the lexicographic order on the free monoid is a linear order in the case when the alphabet is totally ordered. And the next, I propose for you that radix order on free monoid is a partial order. What is a reversal word? If you have word W, which is equal A1, A2, so on, AN, with AI belongs to alphabet A, that is the word of the form W tilde, which is equal AN, so on, A2, A1 is a reverse word. If you write our word from the left to right, the reversal word is written from the right to left, yeah. So and later the terms W with tilde and W with in power tilde, we shall use it as equivalent terms. We remark that for all words U and V from the free monoid, we have that UV is the power tilde is equal V with tilde, U with tilde. It's a very simple property of reversal word. So what is a reversal set? If you have a set X of free monoid, the reversal set X capital with tilde is such element X with tilde, such X belongs to X capital. What if a factorization of the word? If we fix any word W from free monoid A star, a factorization of such word is a sequence, such sequences U1, U2, and so on, UN, where n is a non-negative integer of the word in free monoid A star, so that W is equal U1, U2, so on, UN. Yeah, we observe that the factorization is not unique. Why? So if we have alphabet which consists of one letter A, then A is the power 5, we shall write as the word A, yeah, multiply A. or you shall write a here for a, yeah. And there are many other type of a, and a. So this implies that the factorization of the word in free monoid is not unique. There are many type of methods of factorization. Also, if we have a subset F of free monoid A star, we denote by X star the submonoid of A star, which is generated by the set X. What is this? This set consists of from the word x1, x2, so on, xn from the set X. Example is not very difficult. So suppose we have X consists of A, B, yeah, and we have free monoid which generated two elements A and B. Then X star consists of empty set. These two words, yeah, A and B, A, B, B, A, yeah, and so on. Of course, this subset is a submonoid of A star with respect of this monoid operation concatenation of the force. Also, similar as free semigroup, our alphabet A we denote by X plus the subsemigroup of free monoid which is generated by the set X equal as X plus is consists of non-empty subsets. So and non-empty words, yes, where A, X, and Y belongs to the set X. So if we have in our case, so when we consider previous case, X star, that X plus is X star without empty words. So what we have in the next? If we have what is X plus? So if the set X contains empty word, then this equal to X star without empty word, yeah. And in usual case, if one is element of empty word is element of our set X, then X plus is equal as star. By definition, every word in a monoid X star admits at least one factorization, whose elements are elements of the set X. Such factorization is called an X factorization. We frequently use a pictorial representation of X factorization given in the following figure. So what is it's first word x1, x2, so on, xn, yeah, as usual. Yes, right. And word w, which is equal to the word x1, x2, so on, xn, yeah. So the word X of a Freeman-noid A star is called primitive if it is not part of another world of A star. What is primitive? So if we have A consists of two elements A and B, yeah, maybe C. So word A, B, C, AB, ABC. We have a problem to write as a product other words, yes. This 5 words is not power of other words of A star. But for example, the word on such alphabet of the form AB is not primitive because the square of the word AB. What does it mean that the word is primitive if and only if x is equal y in power n with some non-negative integer n? This condition implies that x is equal y. And we remark that empty word is not primitive. So if we have two words x and y from Freeman-noid A star, we shall call these two words conjugate if there exists word u and v from Freeman-noid A star, such that x is equal uv and y is equal vu. What does it mean? That we have a word x, y. So what is property if there is this prefix u of x? If we put this prefix after v, we get the word y, yeah. And in this case, towards x as y is called conjugate. In this case, we frequently say that y is a conjugate word of x. Two conjugate words are obtained from each or other by cyclic permutation. More precisely, let gamma be mapped from A star to A star defined by the formula. The image of the empty word is empty word, and gamma AV is equal VA for letter A small with A capital and word V from the Freeman-noid A star. It's clear that map is bijection from A star to A star, yeah? Two words ended Y are conjugate if and only if there exists a non-negative integer n such that x is equal gamma in power n of y. This means that we give n times image by map gamma of the element y. So, and we have that this relation which is called conjugate relation is equivalent relation. I propose to prove this exercise for you. And conjugacy class is a class of this equivalence relation. We frequently said that y is a conjugate of both of the word x. And a conjugacy class is also called necklace. The length of necklace is the length of the word in the conjugacy class. A necklace is called primitive if each word in the conjugate class is primitive. So you get 3 exercises. I propose to solve it, and I wish you good luck. Goodbye.